It's been a very exciting day, and we're looking forward to finishing off this afternoon's discussion with a very interesting presentation to start with, followed by a discussion about analog environments. We're going to take this to around 5:30, then give you roughly a half an hour break before dinner and things. But in starting, I'd like to hand it over to Dr. Jeff Ayton, who last year, as you know, we had a real-time presentation from Mount Everest. This year, Jeff and his team with the Australian Antarctic Medical Division are going to start off this presentation on analog environments, speaking to us live from the Australian station in the Antarctic, where it's now 2:30 in the morning. And we'll talk a little bit about ultrasonography and why we can use these analog environments to do space-relevant research. So I'll hand it over to Jeff, and he'll introduce Dr. Browning and the team down in the Antarctic.
Thank you, Dave, and thank you, Dr. Alford and Dr. Abbey, for the privilege of being here and presenting with this telecast from Mawson Station in East Antarctica. Australia has three continental Antarctic stations in East Antarctica and a sub-Antarctic station in Macquarie Island, and our neighbours are the Chinese, the Russians, the French, and the Japanese. And this last summer we've assisted all and in medical endeavours and also in logistic endeavours. And what I want to do is hand over to Dr. Glenn Browning, who is at Mawson Station, and it is 2:30 in the morning, and we're talking about shift workers and circadian rhythms, and this is entirely relevant to them down there. Dr. Browning is an emergency physician with a generalist background, working in Australia's capital territory, Canberra, and he's got a background having wintered in Antarctica for the Australian Antarctic Program at Casey Station in 2002, and this year in Mawson Station. He's undertaken 35 voyages in the Antarctic and Arctic as a ship's doctor, and has worked up at Kundi in the Everest Base, up on the way to the Everest Base Camp. So I'll bring Dr. Browning on the line, and we have a video conference. Morning, Glenn, and sorry for getting you out of bed. Over to you.
Yeah, g'day. How you going there? Hi, yeah, I'm Glenn Browning, and as Jeff has said, I'm speaking to you from Mawson, which is in East Antarctica. Yeah, just like to thank the International Space Medicine Summit for inviting us to participate in this very important meeting and making it possible to be part of your very exciting and relevant program as well. I've got a couple of guys who've been up all night waiting for this. Got a patient over here, one of the electricians, and one of our comms techs, just helping out with the audio-visual stuff. I'll just talk briefly about our situation down here. The physicians chosen by the Australian Antarctic Division are expected to have a broad range of general skills, including anaesthetics, surgery, and general medicine. The comprehensive pre-departure training program includes other skills such as dentistry, radiography, laboratory work, and so on. And here at Mawson, we're pretty much isolated for the whole of the winter. Our nearest neighbours are 600 kilometres away. And as you'd expect, outside it's cold. It's a difficult place to work and live. Inside it's reasonably comfortable, but a typical day outside you'd have temperatures -20, and winds around 20 to 30 knots most of the time. This year we currently have 16 expeditioners spending the winter, and I'm the only doctor on station. There are no paramedical staff. 4 of the staff, including the 2 guys with me tonight, have done a 2-week training looking at operating theatre techniques and patient monitoring under anaesthetic. The last ship left us in mid-February, and we don't expect to see another ship here until next February. We do get our first flight, hopefully, to bring in the summer crew in November. So typically for Mawson, we get about 9 months over winter, where there's really no opportunity for anyone to get in or get out. We've set up the medical facilities down here with that in mind, where all patient care during winter happens on station with no opportunity for evacuation. And because of this isolation and the harsh environment, we feel that the Antarctic program represents an excellent space analogue. We've got a group of real people down here who occasionally suffer real medical emergencies. The project we're looking at the moment is looking at ultrasound, diagnostic ultrasound, and trying to make it a useful tool in the hands of personnel with minimal training. We've got a pre-programmed machine, and we have a flip chart set of instructions advising the user how to set the machine up, where to place the probe on the patient, how to capture the data, and then that data can be transmitted back to a central point for interpretation. We use a store and forward technique, which is analogous with the way that data would be transmitted from space with its transmission delays. I'm just going to step over to the bedside now and demonstrate how this works. You can just see, should be able to see there, the ultrasound's pretty much a laptop-sized unit there, and it's basically pre-programmed. We use a little set of flip charts here with basic instructions, push button A, push button B sort of thing, photos for the anatomical placement of the probe, and then a photo to represent what you should be looking at when you get the organ. In this case, we'll be looking at the bladder, so you've got an idea that you're actually positioned in a reasonable spot. So I'll just pop this probe on here. We've got a cooperative patient here who's been holding on his bladder for some time now. And we have very special Antarctic cold gel here. It's always a good thing. Oh yes, that's good. Okay. So, we'll just come up on the screen now. I don't know how good your picture is on the screen there, but here we've got the bladder, well demonstrated there, and with the instructions we basically get a 2D image and save that, and then with the 4D volumetric mode, what we're doing is we're scanning through the tissues. We just hold the probe in place and we scan through the tissues by pushing the button, and that data gets saved. You can see that we're going through the bladder there. I'm not moving the probe at all. Once that data has been processed, we can save it. And I'll put the probe down. I'll just go through to the stored data now. We'll have a quick look at that, and then Jeff will demonstrate a little bit more what the software can do once you've got that data back home, so that a radiologist can make a better interpretation of what's going on. There's our 2D image there, and our 4D, I'll just quickly show you that. Here's the bladder, and we're looking at it in two different planes, and we can scroll through to see from top to bottom and laterally from right to left in these images here. You probably get a better picture back where you are at the moment of that. So the key is that an inexpert probe placement or orientation by a user not specifically trained in ultrasound technique can be compensated to some extent by the radiologist. Alrighty, you have that, give a bit of a wipe.
Dr. Browning, it's Dave Williams here in Houston. We really enjoyed your presentation. We're going to open up the audience to questions and ask them if they have any questions specifically for you. While we're getting the microphones in position, I was wondering if you could comment on whether or not you feel it's more advantageous to do a store and forward with a trained operator remotely located in the field, or whether you can actually have a distantly located operator mentor someone through performing a procedure and interpret the ultrasound real time with an expert located in Australia or potentially on another continent.
I suppose the difference is whether or not you have a real-time communication with a considerable gap or not. It would be possible to do, say, a video conference with Antarctica and Australia and have real-time input. I suppose the advantage we're looking at here is we're just basically getting a large block of 3D data in a similar way that a CAT scan will collect data, and then that can be manipulated further so that the radiologist back home can look at that data and then just go through at any angle he wants to get a reasonably good diagnostic image.
Excellent. Thanks very much. Does anyone in the audience have any questions for Dr. Browning? Yes, Jeff.
even if I yell. For general medical care, do you perform periodic exams on the other people there, or do you just wait until they have a problem?
So all the exhibitions that come down are very fit. We have very extensive screening programs, so really if you've got any significant medical problem, you're not going to be selected to come down over the winter. But each month we have a formal medical consultation where we do simple things like check weight, blood pressure, but also give each expeditioner an opportunity to bring up problems that they may not have felt were significant enough to bother me, but it's surprising how often you'll get something pop up at that monthly meeting. So there's always that sort of sitting around waiting for something to happen, but we also actively check each person each month.
Any other questions? Jeff.
Hello, Jeff Jones from JSC. We were curious about your ultrasound techniques that you're developing. We had applied zero-G techniques for some contingency procedure development a number of years ago, and then subsequently at Devon Island on the opposite end of the planet, we had developed some ultrasound algorithms prior to flying them on the space station. But are you guys using ultrasound to actually guide any procedures, using the images you acquire for invasive, for instance, draining abscesses or draining the bladder in a suprapubic approach if you couldn't get a urethral catheter? These types of techniques, does ultrasound help you not just for diagnosis but actual treatment?
Within the limitations of the study, we're really only looking at what it would be like for an inexperienced operator. In our situation down here, we've got a trained physician who most of us have some experience with ultrasound, and we're all proceduralists. So we would use that if we needed to. For instance, for a suprapubic catheter, we could happily use the ultrasound machine. But within the limitations of this study, we're really just looking at a flip chart system for an operator that's not familiar with ultrasound techniques.
Jeff, it's Jeff Ayton here. Glenn, we have used for the first time these Volgason ultrasounds have just been deployed in the last summer, and on the first ship of the season we had a multi-trauma case at Davis Station, and the US Antarctic program and helped us out with a joint evacuation after 16 days of managing this multi-trauma patient at the end of winter, and we utilised that machine actually to insert the CVC drain for CVC line with the intensive care team that came down from the US and Australian base. So we have used it invasively to date, but we're very new in this.
We have another question in the back with Kevin.
Hi, fantastic presentation. I just wanted to ask a general question, and that is, in your experience of the caseload that you have from wintering over teams, how often do you have a contingency which you feel couldn't be coped with by a sufficiently trained paramedic with remote guidance? That is, how often do you have contingencies which genuinely require the presence of a physician?
Well, Dr. Ayton knows all the statistics of how often we have a serious medical emergency, but each year I think we would have situations which need accurate medical diagnosis and often intervention which is a bit beyond your regular paramedical training. It's a sort of place where we don't really have an option to fly someone in if there is a medical problem, so I don't think we'd ever run a station without a physician on the station over the winter.
Any other questions? Dr. Browning, we'll finish off by asking you a final question, and you alluded to this at the beginning of your presentation. This afternoon we're talking about analog environments, and you mentioned that you feel that the Antarctic is an excellent analog for what we're doing in spaceflight, and I agree with you, but I was wondering if you could point out to us what you think is the single most beneficial aspect of using the Antarctic as an analog for preparation for spaceflight.
I think the big advantage is that the absolute remoteness of particularly the stations over here, where you've got, as I said, 9 months where we really don't have an option of getting a ship or a plane in, and in a long-term space mission you just don't think, oh, I've got a problem, we'll just come home or get any help. So you've got a very real population of people in a potentially very dangerous environment, isolated for a long period of time, where pretty much if it's a problem on station, you've got to sort it out down here.
Excellent. Well, thanks very much. We really enjoyed your presentation. Very, very impressive demonstration of the technology. All the best to you and your team. And actually, I wish I was there with you. It's always fun being in these environments. Thanks again.
Great. Thanks very much.
Now we're going to hand it over to Jeff Ayton. Jeff has a store and forward ultrasound that was taken in the Antarctic, and we'll just show you that imagery and comment on that technology.
Thanks, Dave. Just to correct, this is actually what we hope to have at the end of the research project at the end of this year. We're collaborating with the Royal Perth Hospital and GE in Australia in using an untested approach in the Antarctic of volume ultrasound. And I feel it helps me as the Chief Medical Officer to make the right calls and right decisions, medical decisions in support of my doctors, to not to just to diagnose the common things, but to send back a block of data that will then be looked at by an expert who can exclude the uncommon things that will make a difference in the decision making about how to manage the patient either over the total isolation of winter or not. This sample, we did send back the bladder sample. We didn't go looking too far elsewhere in our wonderful patient there because of the time of the year, and it's best to restrict that, so we just looked at the bladder. I have got a sample ultrasound from GE that the volume ultrasound that should come up here. And you can see here the 2D, just a 2D store and forward, and we could do real-time 2D guidance as well, and we can do real-time guidance. But here you can see the 3D, the three planes, and of a liver scan, and you've got the diaphragm on the side. I'm not an expert in ultrasonography, but there's some intrahepatic vessels and ducts, I presume, there. And you can see scanning across the liver there in that plane. You've got the other plane, and then you've got the third dimension down there. So it gives me, hopefully it will give me some more comfort in the diagnosis, and when I'm making the decisions whether to try and evacuate or guide the doctors down south on what to do, hopefully will exclude the less common as well as the common things. So lights come back. That's really all I wanted to say, and happy to take any questions about the project from the audience.
Anyone have any questions? Don't be shy. I know it's mid-afternoon. Okay. All right. Well, thanks very much, Jeff. Great presentation by the team in the Antarctic, and really impressive demonstration of the medical capability that the Australian Medical Division has. So thanks very, very much. I'd like to proceed by introducing the panel very quickly. And what we'll do is we'll have each panelist very quickly let you know the environment that they've been working in, their name and their areas of interest in analogs. And then we'll get started on the discussion this afternoon. And the format we're going to use is very much similar to this morning, where we'll be posing questions not only of the panel but of yourselves to open up the dialogue and be able to get a bit of exchange of ideas going. So we'll start with Jeff, just a quick introduction.
Yeah, thanks, Dave. As I said, I'm the Chief Medical Officer of the Australian Antarctic Division, responsible for the medical care and support, screening and recruitment and training of the doctors for Australia's Antarctic program, and which has been in existence from 1948 through to now. We're based in Hobart, Tasmania, and my other hat is I'm program leader for human biology and medicine research. Internationally, I'm the deputy chief officer of the SCAR, Scientific Committee of Antarctic Research, Life Sciences Expert Group on Human Biology and Medicine. So there's an international network of Antarctic researchers who seek to learn how to find efficiencies and safety in caring for temporary residents in the Antarctic extreme environment, and apply it to other extreme environments and the general populace and mankind. So I see, as we've demonstrated, that we have a long history in doing research in the Antarctic, and we have validated the Antarctic as a space analogue, and numerous publications on this in conjunction with the NASA Office of Chief Health and Medical Officer. We've had a agreement in place, a cooperative agreement, since 1993. So happy to take any questions as we go along.
Thanks very much, Jeff. Oliver.
Good afternoon, everybody. My name is Oliver Angra. I'm working for the European Space Agency in the Netherlands as Human Exploration Science Coordinator. Those of you who were here last year might remember that I was talking last year about our brand new ground-based radiation program. That is one of the activities I'm dealing with. But for this panel, more pertinent is the fact that since a number of years I'm ESA's contact point in our cooperation with another Antarctic station, the so-called Concordia station. Now that station has been built by the French Polar Institute and the Italian Antarctic program. Those two entities have created the station, they're operating the station, and because they themselves lack a little bit the expertise in that area, they were fortunately interested in joining together with our interests in pursuing medical and psychological research in that base. Now that station was opened some 4 to 5 years ago, and basically ever since that time we've had various activities there, ranging from technology testing and validation. For example, we've introduced some grey water recycling technologies that we had developed for spacecraft into Concordia Station, and it has been running there on an operational basis, daily basis, in the station ever since it was opened. Another activity that we have there is related to medical monitoring. We've decided before the station was permanently manned with the help of various expert groups on certain physiological and psychological parameters that would be very useful to collect in each crew that is going to overwinter in Concordia. So we've talked about standardized measures for countermeasure evaluation in flight. In the afternoon, for this Antarctic station, we've tried to establish something similar like that. The kind of psychological tools that we had planned in that context have been collected in each crew that is going there. For the physiological parameters, that's where we come again to some technology testing and development, because we're in the process of developing a very integrated medical tool that can be used by medical laymen in order to perform this host of physiological measurements. And we just had tested the prototype of that one in the last winter over season. Now finally, we are also coordinating together with our partners experiments based on regular research announcements. And in that sense, we have a whole host of different topics covered, ranging from psychological issues of group dynamics, how groups form, how subgroups form, how people individually and as a group adapt to that environment, up to physiological and psychophysiological issues, including, for example, in the current season, immunological studies, a couple of projects on circadian rhythms and similar things. Now, that is most of what I wanted to say. At the end, I would just like to point out to another setting that we're involved in. We were fortunate enough to partner up with our Russian colleagues in the Mars 500 program, which has already been mentioned. So also there we have a set of standardized defined measures which are being implemented, as well as a number of experiments that are being performed. And if there's one point that I wanted to make in this panel, it's that one, that the kind of issues that we're dealing with, trying to assure human performance for future human exploration missions, is such a complex one with so many different factors that we need to evaluate. And none of the kind of settings that we're using is really 100% perfect. In the end, only a real Mars mission will be 100% of fidelity to a Mars mission. So in that sense, I think we really need to make use of the complementarity of the different settings, analog environments, simulations that we have available in order to make useful steps further ahead.
Thanks very much. Mike.
Yeah, hi, I'm Mike Gernhardt from NASA JSC. I wear about 5 hats. I'm an astronaut, and the 2 hats probably relevant to today's discussion are I'm the project manager of the new lunar rover project that we're doing, and then I'm also the lead of a new team that we've started called the Exploration Analogs and Mission Development. And analogs are always important, but there are times in a program where they're more relevant. And right now we're trying to define and vet a lunar surface operations concept that we can use to drive requirements for the lunar surface systems. And to do that, we need to take a standardized approach across all of our analogs. They all have their strong points and their weak points. And so we've basically implemented a standardized process where we actually try to answer specific architectural or risk questions to the lunar architecture. We develop very detailed protocols before we ever go out in the field with specific hypotheses that we're going to test, data collection requirements. We prospectively define practical significance if the n isn't large enough for statistical significance, and take a very rigorous approach. And one of the other things that's really important is that we run these analogs with full mission operational discipline, with flight plans, flight rules, and act like it's a real mission. We had a great success last summer where we were evaluating the new small pressurized rover against an unpressurized rover, and without going into a lot of details, we had a great team, we had great scientific support, and we went out and did a very lunar-like mission, and were able, with the metrics that we developed, to actually quantitatively describe the performance in the different modes. Having said that, there are always limitations of some of these analogs. We did this one out in Black Point lava flow in Arizona, and the geology was pretty well understood. So, we teamed an astronaut with a field geologist on 2 crews and did a crossover. And even though I didn't know much about the geology, the guys that were evaluating this knew that. So there was really not room for scientific discovery unless we, stumbled onto gold or something. But so the other analog that I was heavily involved in last year was called Pavilion Lake, and this is up in. It was actually sponsored by CSA. And there was a lake where they found these life forms called microbialites that were thought to be extinct 250 billion years ago. And in this one lake, there are billion.
250 million.
I thought it was billion.
No.
Okay. Well, I always get that mixed up. I'm obviously not a microbialite scientist, but the fun part of that was to work with the science crews to come up with the operational concepts that would intersect science and operations. And we were seeing things. We were using these single-person submarines going deep in the lake, and we were seeing things that human eyes had seen for the first time. And I always tell the story that, in one case you could be the perfect astronaut where you executed these contours perfectly, and you could go swimming by the most interesting thing that had ever been seen in microbialite research. On the flip side, you could have the best scientists in the world with no operational discipline wander off and get nothing done. And so the idea was to develop the flight rules, the targets of opportunities, and things of this nature, and then have the metrics where we could assess the performance. So we're involved in all of that. We're also going to be doing NEMO this year and looking at lander and astronaut interactions with offloading the landers and things of that nature. And so I'll just leave it that I think the important thing is to have an analog that is run like a real mission with full operations discipline. And once you have that, then you can tack on the life science research, the medical research, and things of that nature, and it really means something. If you're doing something that's kind of a put-on thing and it's not quite real, I think it's of limited value. So,
thanks very much, Mike. Pascal?
I'm Pascal Lee. I'm a planetary scientist. I'm based at NASA Ames Research Center. I'm also with the Mars Institute and the SETI Institute. I'm very happy to be here. For the past 12 years, I've been mainly involved with this one analog site on Devon Island, and at this site, running the Helton Mars project. As I look around, in fact, in this room, I'm noticing that about 10% of the population has been to Devon Island through our project. And so I guess my goal for the next few years is to get the rest of you up. We'll be selling tickets outside right after this panel. But I actually agree with everything was said before me, and Mike is right on by saying that no single analog can replicate all the aspects that we need to be prepared for when we go back to the moon or onto Mars. And so the key thing is to really home in on the aspects that are relevant and critically relevant in each analog, if you're looking at a site, for example, and then understand the other things that are going to be of low fidelity at that site, but focus on the ones that are really going to teach you the lessons that you want to learn. Without repeating what was said before, I want to convey this thing. There are 4 functions, and we wrote a short paper about this, about analogs that I think need to be borne in mind. They serve 4 functions. You can use an analog site to learn fundamental things. Okay, we go to Devon Island, for example, to look at the geology of the site or its microbiology to try to learn some fundamental things about the science of Mars and what we might hope to see on Mars or should not hope to see on Mars. That's the learning function. The second function is to use analogs to test systems, strategies, ideas, technologies. So it's the testing function. The third function of analogs is to train people, but not just crew. Ground personnel training is going to be, in my view, a very important thing in the future as we move ahead with these long-term, long-duration, long-range exploration missions on the Moon and Mars. Okay, so the training function is the third function. The fourth function of analogs is to engage others. And it's a broad, cross-cutting function. Others can be the public. Okay, public is attracted to analogs because you go to cool places and they are excited by what's being done. They see hardware being used. It's important to engage students. Okay, analogs can serve a very important educational function by engaging graduate students, undergraduates, just getting people excited in schools about science. And you can also engage international partners. And I often cite the extreme example of a country like, say, Mauritania in Western Africa. Okay. Mauritania doesn't have a space program. However, it has a wonderful piece of the Sahara Desert with beautiful meteorite impact craters that are half buried in sand, several of them. And it is an opportunity, for example, for a nation like Mauritania to be part of a global exploration effort by lending its impact craters for an international team of astronauts to train. So this is just the notion that analogs offer this interesting aspect, which is that they can engage really a broad pool of partners across the planet. Okay.
Thanks very much, Pascal. Dr. Li.
Good afternoon. I'm Yinghui Li from Astronaut Center of China. It's my very pleasure to have here in the noon our director, Dr. Chen, introduce something about Chinese manned spaceflight project. Some people was very interested or direct experiment. So at here, first I would like to have a brief introduce about our result from some bed rest. Last year is 2007, we have a 6 days bed rest experiment. It's about we have some Hong Kong University and CNES participated it. So we have 24 volunteers. Before the 6 days bed rest, we have 15 before essential experiment, and after that we have 20 days recover. With this bed rest experiment, we mainly focus 2 parts. One is for the effect of weightlessness. It's I think normal, but we used Chinese traditional Chinese herb on this. Before the experiment, also during the experiment. The herb is very effective, we found it, especially on the cardiovascular. And another part is for the bone loss. We have the vibration. And also we have some other experiments. We think for this experiment, we found it the two kind of method is different way and different effect. For the traditional Chinese medicine, I think is very is effective because it's normal drugs of medicine, because it depends on different people's situation. Because we have a doctor, the doctor every day we have some traditional medicine diagnosis. So if the different people, the different situation of the different people, they made the different herbs. So that is we had the result is effective because special for the cardiovascular, and we think for the many space in China is made. Some programs make a great progress. Also, we have established some different level research for the cellular, for the mechanism, and for the effect of space element and the effect. We have the cellular and molecular research for the mechanism of the effect, and also with the system function, we have the animal models and also the bed rest. Also, we have the flight experience. During the Shenzhou 6 and Shenzhou 7, we have practiced some. I think it's the Chinese method for as the counter method to the flight. Another thing we are very introduced is the standard from the research this year, at about the beginning of this year, the AF have a meeting. They agree with bed rest commission. They just want to have a standard of the bed rest. So I think it's very important since at this time we found the different result even in the ground research or also in the flight research. So I think the standard is very important, including the proceeding and the method, also the biomarker. Another thing I think we would like to discuss and show is the model. Even lots of people was interesting for the lunar exploring and Mars, but how to establish the model, effective model, I think is very important. So for this question, we'd like to discuss and to think about with the others and share the ideas and share some result. That's all.
Thanks very much. Last year at this time, our next panel member was on top of Mount Everest and summited Mount Everest and was able to share with us a demonstration of ultrasonography from a very high altitude. Christian, I was wondering if you could perhaps comment a little bit on that and introduce yourself as well.
Sure. Thanks very much, Dave. It's great to be here with everyone at sea level this year. And yeah, that was a very exciting opportunity. And I'm a remote medicine physician and a researcher. And as Dave alluded, one of the environments is Mount Everest. And I wintered twice in the Antarctic, once at South Pole for a year as a station physician in 0405. And a number of friends here on the panel. Sorry I haven't been to an expert meeting, Jeff, recently. And also at Devon Island as a medical officer and in 07. But in terms of Everest, if I could just preface my comments a little bit, I think there's some concurrence here on the panel that how important these environments are and that multiple environments are key and that they'll play a critical role in preparing crews for future long-duration missions and that they'll allow us to apply different mission aspects to each of these analog environments and avoid significant cost in terms of trying to do these things in space. And Lauren Leviton's group and many of the members are here. are doing a lot of work on looking at analogs and trying to define what the important aspects are of each of these analog. And these are, I'll get to Everest and Antarctica in a moment, but I think this is really important. And if you will, I've distilled it down into 5 key areas: physical environmental factors, and under that would be how similar it is to lunar Mars terrain fidelity, physical isolation, so how isolated are you? And these are all under physical. Environmental threat, what's the threat to life? The second one is mission characteristics, so what's the mission duration? The mission task relevance, operational timelines, operational discipline, as Dr. Gernhardt alluded to, workload, so that's mission characteristics. Then we have the third one, which is human resources. So what's the leadership like? What's the crew size and crew composition, gender, specialization of each one of the crew members? Number 4 is station characteristics. So what's the confinement? And that sort of speaks to social isolation. You're with 6 crew members for 2.5 to 3 years. That's a significant issue. Habitable volume. What's the size of the volume you're going to live in? We look at some of the mock-ups for the lunar surface. It's not a lot of volume, especially when you're thinking about 6-month missions. Life support conditions. What's the quality of the lighting? Personal space, rest and recreation. You can't work these guys all the time. We know that from Antarctica. Having spent a year there, it's very, very onerous. And then medical care autonomy, which I think a lot of us are interested in here. So physical environment, mission characteristics, human resources, station characteristics, and medical care autonomy. So how do all of these analogs fit into that? And again, I applaud Lauren Leviton and the group, and it's exciting to participate in that. And I think each one of them has specific characteristics that they can fulfill in terms of preparing for missions. And when you think of, for example, Mount Everest, we did some exciting work there with the CSA Operational Space Medicine and looking at an operational medical control. It scores very highly on the physical aspects. So there's a large threat to life there, you're isolated, etc. And so that allowed us to test an operational medical control via telemedicine. We did some exciting work with Scott Delchevsky in looking at ultrasound and ultrasound-naive sonographers. In terms of the Antarctic, well, that scores very high on mission aspects, so duration, task relevance, mission timelines, workload. You think of climbing a mountain, workload is quite high in the Antarctic. The other place where Antarctica tends to score very high is on the medical aspects, and we had a fantastic demonstration there from Dr. Browning, and brought back a flood of memories, although I'm not sure I'd trade places with him today. It's a beautiful day here in Houston, but when we think of difficulty of evacuation, autonomous medical care, that's really what I think it's going to be like trying to take care of crew members on a 2.5-year mission to Mars. You're it. And I think there's a lot that telehealth can do, both in a synchronous and an asynchronous environment. And this past summer on Devon Island, we did a very exciting project looking at asynchronous telehealth. And I think it will provide a significant benefit to providing assistance to a medical crew officer. But as was alluded to earlier, when something bad happens, really bad, the first line of defense is going to be the crew medical officer. And we see that in the Antarctic. When it comes to life-saving procedures, you've got to have a well-trained individual, I think, on that end of the pointy sword. So maybe I'll end my comments there.
Thanks very much, Christian. And we'll finish off with the panel introductions with Mark Regan. Mark?
Good afternoon. Mark Regan from Johnson Space Center here. I have been involved with the NEMO project since 2000, which was when we started putting it together. NEMO is a collaboration between NASA and NOAA. We use NOAA's undersea habitat Aquarius, which is the only operational undersea habitat in the world today. And we design analog missions, and we take crews of 4, which are complemented by 2 professional aquanauts from NOAA. And we do missions that range from about 6 days to 18 days is the longest we've done. And so this is located near Key Largo, Florida, and we just design missions with a lot of operational rigor, timelines and real-time replanning every day, and just run those out with real types of scenarios. Telemedicine has been the theme on several of the missions. We Did some looking at autonomy with very long time delays on a mission, and my role has been as an aquanaut on one of the missions, and for most of them as the mission director. So we've done 13 of these so far.
Thanks very much, Mark. I've had a chance to participate in 4 missions in my spaceflight career. 2 of these were space flights, 2 of them were underwater missions. And as everyone in the audience knows, when you speak to an astronaut about the experience of participating in a mission, the crew members become like your family. I remember floating through the hatch into the space station, and Fyodor floats up to me and gives me a big hug and says, "Dave, it's great to see you again." Very tragically, last week, one of our colleagues on the Aquarius Undersea Research Habitat perished in pursuit of a joint Navy-NOAA mission. Dewey Smith was age 36, and very tragically and very sadly he was found underwater and unable to resuscitate him, and he was brought back into the habitat. And I think this illustrates the risk associated with the environments that we work in. It also indicates the fact that we're all very close in the pursuit of our goals and exploring and working in these analog environments. And I'd like all of us to take a minute's silence to think about Dewey, our colleagues, and others who have perished in the pursuit of exploration. Thanks very much. Most of you have had an opportunity to work in doing research in analog environments. How many of you have had experiments in any one of the analogs? Yeah, in the back. Dave, maybe you could comment on your feelings about NEMO and what you...
Well, I have to say that the original reason we got involved with NEMO, original reason we got involved with NEMO turned out to be not the real value of it. It wasn't until we realized that astronauts were going to be so incredibly cooperative and provide so much data, and which allowed us to develop norms that had a sea change in our thinking about the value of NEMO, for example. And that actually accelerated our algorithm development for our ISS COG tests, the PVT. And so that, from my standpoint, it started out as an unknown and ended up as a home run. And it took about 3 NEMO missions for that to happen, aggregate enough data. But an incredible compliance. And also we realized, this will be no shock to the astronauts, that you can't really use normal people norms to norm them. That you really do, the most valuable thing is to get their own functioning in your database, because their inter-subject variability is smaller than the population normals. And because of that, you can set more rigorous thresholds for what off-nominal is, and you can interpret that, I think, in a more meaningful way. So as opposed to crude clinical thresholds, which we still need, but you can give them a sense of, how they're varying around a norm. So that was very, very useful. The interface work we followed up with by calling them up and asking them to look at the nature of our interface, which we realized may look good to us, but may not look good to them when they go to use it. And we got a ton of information from that, and it also changed everything we did. And then that has accelerated the Russian chamber study work that we're now doing, as well as some additional feedback work we got from Devon Island. So on the whole, we found the analogs very, very useful and actually an extremely efficient way to get critical information.
Excellent, thanks. Well, we're going to open this up to the panel and anyone else in the audience that wants to comment. This morning, we were talking about the challenges in getting the data. We need more than N1 science. Well, now we've talked about the value of analogs in getting that data, but that data does not necessarily come from astronauts. In the case of NEMO, it might. How do people feel about this? Does anyone on the crew want to comment? Mark, perhaps you've coordinated 13 of these NEMO missions. How many of them have had science?
All of them. and the science got more aggressive as we matured. But with NEMO missions, we had, as I mentioned, 2 professional habitat technicians, 2 professional aquanauts on this crew of 6, and generally between 2 and 3 astronauts, but almost never were all 4 of the NASA crew members astronauts. So typically we would come back with all of the crew participating, and sometimes even the topside team participated. I was a subject on some of David's science, in fact, during our topside of one of our missions, but everyone was very willing to participate, and all of that data went into the N, not just the astronauts. And I think it's an interesting comment that the astronauts tend to be normalized to a little bit tighter extremes, and I would submit that probably anyone that is operationally well equipped and is interested in doing that kind of mission probably falls in that same categorization. So hopefully we were able to get more of a meaningful end from all of that as well.
What about anyone else in the audience? Any thoughts about that? Yeah, Kaz. Just get the microphone up to, please.
Yes, this is Kaz Shimada from JAXA, and we have 2 crews participated in the NEMO so far, and I personally think we had a great success in that. And in particular, now the assignment interval of the astronauts are so long, but NEMO is a real mission, not a spaceflight mission, but it's a real mission. And so human factors and aspect is great. And also, people have not discussed this, in a passionate way. But some hardware is tested when BME, biomedical engineer from JSC, participated in that. And I want some of the hardware like an exercise machine, tested there, well tested there, and that should be a better machine.
Well, that's an excellent point. These are real missions. So what can we learn in these environments? Yeah, Judy.
Thank you, Dave. My question is addressed to Cristianato. I heard your presentation last week at ASMA, and all of our discussions here today really have addressed medical technologies and physiological concerns. I was wondering if you would mind commenting on the things that we should think about for Mars missions based on your Antarctic experience.
Thanks for that question. I like to say, or open presentations by saying I'm an operational guy. And but I really think that the BHP factors are critical, and after we've dealt with the issues of 0G and the effects on the physiological system, I think that the psychological factors are showstoppers. And I even wrote down, Dr. Morikov said psychological aspects will be significant. And I think one of the problems is NASA's done such a brilliant job taking care of crew members for 6 months, and we've got a number of people here who've flown on ISS. They're just so well taken care of. And when we go to the Antarctic program, fortunately we don't do such a good job, and people are there for a year, and we have a lot of experience. As I've alluded to before, we have 4 cosmonauts who've flown in space for a year or longer. That's all the long duration experience. We have accrued long duration experience, but the effects on people who've been in that environment for up to a year, and we're talking longer in mission to Mars, 2.5 years. I don't think we truly comprehend the effects on that, and my personal feeling is that it affects our biology to the degree that we see neurostructural changes. I think there's a chemical basis for that. And I think in the time that I've been coming down here to NASA for the past 10 years, I see a real shift as there's a shift to exploration, a real sort of appreciation, and it's spreading through the CB office as well for, these are real issues, and how are these people going to get along for 6 crew are going to get along for 3 years. In the Antarctic, we see a lot of problems. We've had close to 1,500 people now winter at South Pole for up to a year. Jeff and I we've been talking about this since Thursday, just the effects that this has on people. In the U.S. program, we call it people get toasty. It takes them 6 months to a year to recover their cognitive function, if you will. In the Australian program, they call it the polar eye. It's really given me a lot of insight spending time in Antarctica, and it's allowed me to connect the dots, if you will, on something that I think is really important, and I think a lot of people here also are starting to feel that that's an issue.
Helen Lane from Johnson Space Center. To follow up on this, I was a project manager for a 91-day isolation study, and I wasn't in isolation, but the other people were. And I guess the two issues, first issue is what is isolation? Is that isolation so you can't get out of it? Is that isolation from communication? Because, our forefathers had real isolation from communication. Or maybe there are other factors. It's the constancy of the same environment. I felt like on our 91-day study that we had such strong communication between the outside world and the people in the chamber that although the chamber was great, like NEMO, great for testing hardware, I'm not too sure we got to what you all are talking about as isolation. So I guess I'd like a better understanding of what we define as isolation and what are the kinds of things we can do to remediate it, like communication.
Just in response to that, I went to that Casey station in 1992, and our communication in those days was by telex, and so Australia's program has got some 20 years. Back then I was logging electronically all health events for all my team and doing the monthly medicals and the midwinter medicals. And we've got 20 years, over 1.3 million person days of data, of health event data on the experience in Australia's Antarctic program. And sure, communication has increased from over the last few years. We now have 24-hour internet access and telephone capability. So those changes have happened recently, but the isolation still exists because we've largely been a ship-based logistic program, and it was only last year we flew the first flight of an Airbus down to Casey Station and an air link between Hobart and Antarctica. So there's two aspects to that isolation, and I agree the communication is one, and the real absolute isolation of over winter of real people doing real work in a real hazardous circumstances. I tell them before they go that I can't evacuate them over winter, and even over summer I'll only evacuate them for life-threatening or limb-threatening conditions. It's managed down on station.
Dave, if I could just add a comment to that. I completely concur with Jeff in terms of the isolation. I also look at isolation as environmental monotony. You're stuck in the same place, looking at the same view all the time. We don't have the same breadth of diversity that we would have in our regular lives in terms of the environments that we're exposed to. The other important factor, I think, is duration, which we're missing out on. I think confinement is a big issue as well, and I look at confinement as social monotony, and also it has plays a role in sort of the habitable environment that you're in. And it's interesting, Mike Foale mentioned how he felt after his Mir mission, and I think we know the communications on Mir were much less. There was some email, but not nearly as much comm. There was obviously some stressful events. I think stress plays a big role in these environments as well.
Rick String again, and I was actually fortunate enough to participate in the 2006 Lunar Medical Contingency Simulation up at Devon, and I think one of the things that became very evident to me and the team was that remote environment brings out the unknowns that you don't necessarily plan for to try to figure out when you're doing these, but it's just the remoteness and the isolation in the environment that brings out things that only those analogs can do. That was just a comment because I really believe in the analogs. One application that I don't think was brought out was was verification and validation of our requirements. It was something that we're trying to do. We have over 400 requirements in the Human System Integration Requirement document for Constellation, and at least recently a number of the requirements we've had have come under fire on the engineering side. We've wanted to actually use the NEMO to validate a number of our requirements. I think that the analogs are a very useful environment to actually do that, and we'll continue to do that. However, getting funding and doing that has been quite difficult in the past because it's viewed as somewhat of a boondoggle. And I've faced, as well as I'm sure the panel, the frustration of trying to get an operational message across to non-operational people who have not done field work before. So I wonder if the panel has any recommendations for how we win that battle. That I've talked with a number of the astronauts who've done missions also, and have faced a similar problem. But I'm curious what the panel's thoughts are on that.
Yeah, panel, come on. Mark, Key Largo, it's 85, 90 degrees, sunny every day, and you're scuba diving.
Yeah. I would say that's probably one of the biggest things that's hindered the NEMO project, is just the perception that how could this be worth anything when it's 85 and you're scuba diving every day. I don't know what the answer is. I suspect that if we talked to everyone in this panel individually, we would all share the same frustration with that. I personally had 12 to 14-hour days every single day, starting 3 weeks, or starting a week before the mission and lasting until several days after the mission, and just really little downtime, no sanity time. It was a pretty stressful and intense event, and that's all just not seen. It's still Key Largo, palm trees, margaritas. Why are you harassing us with this analog stuff? Yeah.
So, Rick, I would add that and I think we're being successful with this EAMD group, but if you have specific hypotheses that you're testing, and you have good science, and the program recognizes the value and how that will affect decisions they make, for example, with respect to the lunar architecture, then it's an easy sell. It's a tougher sell when you have sort of diffuse objectives and it's in a nice place or it sounds exotic and so forth. Then you can get the boondoggle accusation. But if it's hard science, if there's specific objectives and hypotheses that you're testing and they make sense, then it's an easy sell. And if it's not, then you ought to think about why you're doing it.
And I wonder if there's some confusion because people hear about these different analogs, and so that gives a message of confusion, yet I think what we're hearing here is that each analog has something specific to offer. And NEMO, on these ratings, I think scores very highly on the human aspect and the station ship aspects. Devon Island scores very high across the board. So I don't know how to get that message across.
Pascal, and then Jeannie, you've got a question as well. So
yeah, I might chime in quickly. One of the strengths of Devon Island, I think, is the fact that you have a vast piece of real estate, of territory that is open for you to explore scientifically and methodically. And in fact, we've been very happy to have a collaboration with Mike for the past 2 years, precisely because his overall approach is bringing a lot of rigor to how we conduct our measurements and our experiments up there and what exactly needs to be extracted to inform the lunar architecture. But having said that, the opportunity that's offered by the site has to do with this territory that you are given to explore. And this is why it's so important and different. My understanding is that, if you look at how you operate the shuttle or the ISS, at some level you have long duration missions, or maybe it's just like flying. It's long hours of boredom punctuated by moments of terror. Okay, so there's a certain monotony that comes along with these long duration space flight experiences, especially aboard the ISS. Okay. If we look forward at what it's going to be like to explore the Moon or Mars, okay, there will be that aspect of a long duration mission, but there will also be this whole issue of exploring the unknown with rovers, presumably, okay, on a almost day-to-day basis, okay. And in the Devon Island context, this is where the moment of terror comes in, okay. When you're at camp or when you're in your Antarctic station, I actually spent a year in Antarctica as well. I'm sure many people have here apparently, but I was in '88, and incidentally on that aspect, we were only given one telex per week with our families, and it was limited to 70 words. And that was it. You send 70 words, and then 3 days later you get 70 words from your one point of contact. And that was it. Okay. And it's fine. By the way, we were very happy. Okay. You're not burdened by the problems okay. But going back to Devon Island, the key thing was was when you head out there with your rover, and even if it's a low fidelity rover that's not a moon rover, fine, you note that infidelity. But the key thing is that you're nevertheless out there. You are on your own. There is no infrastructure to support you other than what you've brought yourself. You have very limited medical support. You are faced with possibly getting stuck in sand, in mud. There's the terrain to navigate. There's, of course, the planning that you do before you set out, but at the same time, there's the reality of what you encounter. And my point here is that you are running into unknowns that you have to address and manage, and risk, and decisions that are constantly coming your way, that are really challenging for a crew, and will be super challenging in the case of the Moon and Mars, because there will be unforgiving decisions to be made. And so that, to me, that's sort of maybe the fundamental difference between even what was done on Apollo, where of course we had EVAs, but they were very planned, orchestrated, limited in time and range and scope, versus trying to really advance lunar science at this stage, which will entail doing long-range driving on the Moon and Mars and into unknown territory. And remote sensing can only tell you so much about what's ahead of you.
If I may make a small addition to that. The things that Pascal talked about in the end are one aspect of isolation that hasn't been so obvious in our previous discussion. That's the need for autonomy of the crew, not only in the medical sense, but in any aspect of the mission. Now, at the same time, in my comment, what I wanted to do is to try and break a lance for the non-strictly mission-operated ways of using analog environments. I mean, I certainly fully share your conviction that it's very important to do those things when you have a commitment to doing a lunar mission, when you have specific operational tasks that you want to try out. At the same time, just from my European perspective, where we don't have the commitment to go to the moon in a certain time frame, and where we don't have the operational need in order to develop those systems, I still think that the kind of activities that we are doing that are not so strictly guided by the mission setup are still quite valuable. And the reason for that is exactly in what was mentioned here, what was mentioned from the audience about the unknown factors that are coming out. It's not only the unknown factors that you can predict, it's also that we've mentioned the long duration of a Mars mission. We've mentioned that the crew will be very far away and communication will probably be limited. So the whole setup of the mission will probably not be very similar to the ISS, will not be very similar to the way that the lunar missions in the Apollo time were done, and probably not even very similar to how the lunar missions in the near future hopefully will be set up. So in that sense, I think it's useful to just look at these analog environments where real operational work is done by isolated teams, and try to also feed in the lessons that are learned in these environments from a very different perspective in order to then improve and adjust the way that we are maybe thinking about setting up space missions.
Jeannie.
Yes, I had an unrelated question back to Dr. Lee. I wanted to go back to what you said about your bed rest study at the ACC. Did I understand you correctly to say that you thought the traditional Chinese medicines were more effective because they were applied specifically to the individual subject response? And can you share any of the types of herbs that you use for cardiovascular? And I'm assuming that's for orthostatic intolerance. Is that correct?
My means is normally if we, for the people take the medicine is as a pill, everybody has the same amount, everybody the same pills. But for the traditional Chinese, because we have a doctor, we see the people's different situation. If it's this one may be better and this one may be badly, it's a different situation. So the herbs is different. The different compounds. For example, like the A is more and the B is lower, and another people maybe we put at C, so it's a different compounds. So that is why the different people is depend on the people's situation. But the name for, because I'm not the medicine doctor, so the name is very complicated. I couldn't remember it, but I can send some mail to some lots of its plants, I think. Yeah.
Yeah, up in the back.
Patrick Maloney from Rice University. A question on analog environments. This isn't my field, so perhaps you can enlighten me. A number of my colleagues are in the nuclear submarine force, and they routinely spend 3 to 6 months under the water, pulling 18-hour shifts every single day. And is that population, that number is now in the tens of thousands, if not more, looked at as a data set for analog study?
Yeah. In fact, we used it for some of our calculations of what.
Yeah, can we get a microphone to Jeff?
Yes, in terms of the submariner population, we use that as one of our analog sets for determining the likelihood of having specific on-orbit medical events on the ISS, help it for developing drivers for space station. In fact, we have a couple of folks that are in the Navy or had been in the Navy that helped us with that research.
So I guess that begs the question, I mean, what is an analog? We've got another question up here.
Yeah, I was just saying, I had one other question I wanted to ask the team. I mean, we have, Christian, you brought out Antarctica, and I've been to the South Pole too, and I know how isolated and cold it is. And Pascal, been up to Devon with you, and I know how important it is to have a geologically relevant site with a preserved meteor crater to study. And Mark, I've dove with you down into Nemo and experienced the partial gravity environment you can simulate in that environment. So the question is to Mike Gernhardt. Mike, how do we have enough money with a paltry amount we get each year to keep the infrastructure of all three of these places going and still have relevant programs? How do we do that?
Yeah, that's a great question, Jeff, and we really don't have the money to do all of this every year at a high level. And the approach we're taking is to basically focus in on specific years, on specific environments. Last year, we had a very strong focus on desert rats to evaluate the rover for 3 days. This year, we're going back out there for 14 days. I'm actually going to live in the rover for 14 days, and we're going to experiment with some of the things that Oliver mentioned with degrees of autonomy. Last year, we ran it just like an Apollo mission with total calm. This year we're going to go to partial calm. But what we've done is establish these standard measures, so we're going to see how well we perform with more autonomy. And I actually think we'll probably perform better that way, but we'll let the data show that. Devon Island, for example, has this, the remoteness, the lunar-like landscape and so forth that is better than desert rats. Having said that, we don't have the funding to get our rovers up there and so forth, and so we're not going to do that. And this year we're working with Pascal, and we're with a very limited amount of NASA dollars, we're going to get some relevant ops information. Sometime in the future, we might focus all of our assets on a larger mission in a different environment than Black Point, and so. We don't need to spend a ton of money everywhere every year, or we'll get sort of a little bit of nothing out of everything. And so I think we just have to prioritize, and of course the international aspect of this is huge. So, CSA funds a lot of this, and ESA wants to get involved, and I think that's another place where we can explore international partnerships as we evolve these analogs.
Just a quick comment on resources. We're looking for money for another NEMO mission this fall, so if anybody has any funding. We got a question up in the corner up there.
Yeah, I have a question for our Australian colleagues and for Dr. Otto, based on your Antarctic experience. Can you estimate, or do you actually have numbers that would indicate what proportion of the serious events, medical events, have been psychological events as opposed to other, I can't say physiological because psychological events can also be physiological, but other organ system events?
Yeah, thanks for the question. pulled the data on from our health register the night before I came over, actually, and from a total illness perspective, we've got rates of 2.9 health events per person year. From a mental health perspective, we're looking at things like insomnia, sleep disturbance, going on to depression, anxiety, those sort of things. Where my predecessor, Dr. Des Lugg, he pulled the statistics from 1948 through to 72 and came up with around about 4%, and it's still the same. I suspect there may be a little bit of a kick up in the last few years, and we have had a significant tragic event in 2006 with a suicide at Davis Station, and which I managed, and which was very tragic. But generally, people do very well in the Antarctic in the isolation, and because we screen, we have a psychological process for screening, and people find that it's in some ways salutogenic working in an isolated extreme environment.
Our experience has been the same, and one of the joys I had my year at Pole was going through 12 years of medical data, and our incidence is probably, I could calculate the numbers, but from the data, probably 5 to 7%, but that would include depression, anxiety, acute stress reaction, bereavement, adjustment disorder, and insomnia. Insomnia is a big chunk, and when we graph insomnia, it increases through the season, and actually my feeling is that that's a reflection of some of the stress that we're seeing. When you look at the numbers for depression over a 12-year period, and this is fairly recent, it's 2%. And this is a group that's highly screened, interview, personality testing, and that's depression requiring intervention from the physician and pharmacological support. It's 2%.
I've got a question from Dave in the back and another question here, if we can get the microphone down to the front.
And if I just add, it turns out to be one person per season, roughly.
So, listening to this, I'm reminded this is like arguing over which one of the fruits in the basket of fruit is the tastiest and the prettiest. And obviously, the analogs have different functions. And I think what Mike said is right. There has to be a prioritization. There's limited resources. But wherever possible, if once you prioritize a given analog, I would ask that NASA think about what else could you put in it without disturbing that original priority that would help leverage some of it. But my question actually is to someone not on the panel. It's to our Russian colleagues. They are running now a 105-day chamber study, which some of us are fortunate enough to be involved in. And this is a critical analog that's arguably, if you will, pilot data for the big one that's coming. But I wonder if they would make some comments about the 105-day simulation, which doesn't deal with the lunar terrain or anything, but it deals with a long mission and isolation.
Dr. Bogomolov? Or Dr. Bogomolov, would you like to comment on the 105 days? Oh, perfect. Oh, there you go. Excellent. Good.
Небольшой комментарий.
Just a small comment. Everything that I heard here today was very impressive. I'm very impressed. And I salute your bravery. Bravery of the people who agreed to participate in this research, first of all. Secondly, just a little bit about our experiment, because tomorrow we are going to have a presentation about it. 105 days of isolation. This is an intermediate experiment of Mars 500 series. The final experiment will be 520 days of isolation. We modernized our facility for that. We have some additional modules in order to keep the resources for all the required time of installation. And for that, We even prepared a Marshall kind of terrain type of simulation, but this is all ahead of us. The first experiments already demonstrated that it is necessary to have a new approach of selection of people for this kind of test in order to form a crew. And for distributing the roles of the crew members. We already have a protocol, but we need to make sure the right people are selected and appointed. We had a certain standard approach for selection, which is standard for the Russian space program, when the international crew was put into survival mode in winter time. And they were supposed to use the cosmonaut program to make sure they can get out of the vehicle, build a shack, and spend 3 days beaconing about their whereabouts. Also, we had a simulation of trauma of one of the crew members. It was very enthusiastically received, this proposal, by our candidates for the crew members, and at the same time it was a psychological test because 3 independent groups of psychologists were watching them, were monitoring them all the time from the beginning to the end. That was a group of psychologists from JCTC. We had a group of psychologists of our psychologists from the Institute of Medical and Biological Problems, and we had psychologists from the Moscow State University. All of them independently had their monitoring and conclusions for each of the crew members. And were proposing the setup of the crew. And then they combined their resources. The future backups and the main crew candidates were training. The psychologists were watching them again. We had special psychological training, we had interviews, a number of them. And in the very end, we also had a questionnaire sort of inside the crew, asking, whom do you think you want to be a commander, whom do you think should be the best candidates for a flight engineer, and this kind of stuff. And all of that was put on the table all together. And we had a great match ratio. We found a great crew, and it is still working now. Also, the preparation of the crew was great. It was also standalone kind of training. That was a scientific experiment at the same time. We have a great science program. And actually to absorb such a huge volume of material and learn it, it's very, very difficult. From our point of view, a person who would actually go for that kind of test, and it will be probably even stricter for the interplanetary flight, this person should be able to learn by himself or by herself and be open-minded and remember something that they have forgotten for a long time, and at the same time absorb new information. And we do have some interesting good results of that. So training is important, and we have to teach a person not only to use a procedure, but to make sure this person can use this documentation and his or her knowledge at the same time, use the situation, use the new information that may be added at the last moment, and make the correct decision. So that's all I wanted to say so far. I think tomorrow I will tell you some more.
I have a quick question for you, though.
Маленький.
Our Australian colleagues pointed out a 4% incidence of behavioral issues in the Antarctic. Do you see a similar rate in these isolation studies? Yeah.
May I just follow up on this? I'm privileged on behalf of NASA HRP and its director to participate in this 105-day study. And I have to say there's one issue. There's one issue actually relevant to this particular panel. We talked about politics involved in the in the space flights and so on. The next stage of this project is Mars 500. It's an absolutely unique experiment which is coming next year. But we on the U.S. side technically cannot participate in this because of the politics. So maybe we all need to kind of provide our inputs and our recommendations that we could participate in this,
Yeah, I think that's an excellent point. This morning we kept hearing the value of international participation. It would seem here that there's a classic opportunity that we should be participating internationally. Any comments on that, Larry? Just need a microphone in the back. And if you've got a question, put your hand up just so that we get the microphones in place and we're not losing time between questions. Yeah.
Dr. Borgobolov, this is stereo. A follow-up question for you. You said that you found that you had to select differently for the simulation subjects than you would for cosmonaut crew subjects. That could be a very important factor. Can you tell us a little bit more about that? Does that in any way invalidate the results of the simulation? Can you no longer extend the simulation to the real crew?
Ну вот я немножко сказал уже об отличиях, потому что...
Well, I have already mentioned some differences.
Испытания для экипажа приготовили
because we prepared testing for the crew before the start of the simulation for compatibility. And it was important for us that the people were professionally prepared. In our crew, we had 2 cosmonauts who haven't flown yet, but that is already important. One of them is a researcher, and he is a commander. And the other one is a flight engineer, a Russian one. He is a specialist from RSC Energia. He will be a specialist in testing. We also have a physician, a professional practicing physician. We also have a specialist on physical training, and we have a European agency participating also. We had 2 candidates from Europe. We took a lot of time selecting in Europe, and our specialists participated in that as well. So 2 people out of 4 were selected at the final stage already. So this is, so we have another pilot who is a commander of Aerobus 320 and a German engineer, so a French one and a German one. These are the 2 Europeans. I think it would be hard to find a better crew than what we have. So I hope that in the next 500 days experiment we will have a crew which is like that, even better.
Excellent. Thanks very much. We've heard a lot about these environments to collect data, but this is the first comment we've heard about these environments for training. So I'd just like you to think about the value of these environments training crew members as we continue with our questions. We had a question, I think, from the back up here. Any questions? Yeah.
Thank you. I'm hearing some frustration at times how analog environments are not somewhat perceived as they should be. I also participated in some bed rest study as a scientist when I was doing that. And I noticed at times that what we were working on that seemed very promising never really made it into space. And of course, that's very hard. However, I think, wouldn't that be an idea just to have a path, a flow that once we select something that is ready, that is interesting to go to space, it's not ready but interesting, then we start at a lower level. Then we, in our labs, then we go into a bed rest study, and then by default we go into an analog, and then we go to ISS, and then we say, okay, we have proved this works. That would make a pathway that would not leave anyone, out, and also allow for the community to start planning. What is the flow that I have to follow? And I pose this to the panel, whether they think that's maybe a viable.
I wonder if I could just comment on that, because I think that's a theme that I've been hearing as well. And Dave asked what the definition of an analog was, and I think it represents some element of a lunar or Mars mission. And Pascal and Oliver alluded to, analogs being used for assessment and obtaining operational information. But I think it can also be used for training. NEMO would be excellent for operational timelines, Devon for fidelity of exploration, perhaps Antarctica for isolation and medical training. You can actually use all those environments for that. But what happens if you were to use these environments for training a crew? If there was a decadal program for training a Mars crew, you might have basic exploration training either at Knowles or Cold Lake, something like that. Then core exploration training where you might use Nemo, Devon, and Antarctica. Progressing to, an advanced Mars exploration training program where you might use the ISS, say, for 3 months or 6 months to simulate a transit. You go to a lunar station for 6 months. I think you need to go longer, 8 months, maybe a year, back to ISS. And that, in a sense, ISS and the lunar station become an analog for Mars. So you sort of have this triangle going to the peak, which is ultimately your Mars mission.
Mike, did you want to comment on that?
Well, I was going to make a couple comments. One is, I think you're right on with using the analogs to validate procedures and hardware, and we did that a lot with NEMO, and we learned tons of things that you ought to be learning on Earth and not when you get to space. In fact, we learned things that would have messed the experiment up had it gone to space, that by running it through NEMO, we figured that out. And then the other aspect of training is, and just for example, like in Pavilion Lake, we have these one-man submersibles, and we can't take 10 astronauts up there. There's only like 6 pilots and so forth. But we're trying to evolve a change in mindset. Right now with astronauts, we do missions. They're very scripted and so forth. And as we go to the moon, we need to fashion astronauts into instruments of discovery. And we need to change the way we think about things and really convert us into field operational scientists. And so like this year at Pavilion Lake, we're going to have a couple astronauts, maybe 3, but we're going to be an integral part of the science team. And so they'll do a shift flying this sub. They'll do a shift on the science planning team. They'll work with the sample collection folks and get under the microscopes and really work all aspects of this integrated science process. And I think, and we're doing that with rats, and we're going to do that in these other missions. And I think over time, it really helps you to be a better operator in the astronaut role if you understand all other aspects from the planning, and we're even going to participate in the science publications and so forth, so that you really have the whole big picture. And we want to start doing that now in these analogs, because the last thing I'd want to do training for a lunar mission is to get all this science stuff dumped on me in the last year of flight. And if you get people's minds working on it now, they're going to do their own education, and every time they look at a rock, they're going to think about it. And it really offers us a great opportunity to really establish this culture of field science within the astronaut office.
Oliver, you had a comment as well.
Yes, I just wanted to address another aspect of the question that you had posed, and that was to have a clearer path from the analogs up to space. What I would suggest, even though it's certainly not always the case and not for every activity that we are doing, but to a certain degree that path exists. And a couple of examples, for example, in bed rest are in 2000 we did this long duration bed rest study together with our colleagues from JAXA that in one of the experimental groups looked at bisphosphonates, and to a large degree also based on that data, JAXA has been implementing the bisphosphonate experiment in space. Another experiment, even though there's of course a troublesome history around it, is the flywheel exercise device, which also has been extensively tested on the ground. We've validated it very well in bed rest, and now it's up in space and will hopefully used by you in a very good way. So in some cases that path exists and is clearly in the mind. On the other hand, there are uses of analog environments where there can be some benefit which is not directly translated into space but is also supporting. For example, for Concordia, one of the things that I've done is to ask our training people in EAC to help out with some of the psychological training of the winter overcrews that are going to overwinter in Concordia, which is an aspect that had been planned before by our partners, but in the end was not materializing from their side. So on the one side, it's something that we could contribute in order to make the winter over periods a bit safer and more successful, hopefully. And at the same time, it's an opportunity for our side to have some cross-fertilization with a different crew, with some other perspectives that can maybe also educate us a little bit about certain problems, certain examples of things that can happen that maybe should be also discussed in the kind of training that we do for the astronauts.
Pascal, you had a comment, and I think we have a question.
Yeah, just a quick word to build on, I think something that Mike said that's really important. I actually don't see how we can go back to the moon or be really effective on Mars, okay, unless, and I'm talking about being scientifically productive in the geologic and, in the case of Mars, biologic exploration of Mars. I don't see how we can conceive of a scenario whether we go sortie missions on the moon or with a lunar outpost in the future, okay, without having as a central element of our exploration architecture a pressurized rover system. At least 2 vehicles probably, okay, just because it's all about covering ground and seeing the unknown. And you have to go meet up with this information. The geologic information on the moon is all scattered. The biological information on Mars is going to be all scattered, including the absence of information. Okay, so, but the point is you have to get to this information, and you're not going to walk there. So, a pressurized rover system, in my view, and this is actually corroborated with our needs driven from just a scientific exploration of a place like Devon Island. It all has to do with a rover-based mobility system. Okay, and if you look at this now, then you realize that these pressurized rover expeditions on the moon are essentially going to be expeditions within an expedition. Just very much like an EVA is an expedition in some sense within a spacecraft mission. A pressurized rover traverse on the moon will be very much an expedition within an expedition. And in addition to simply training the crew on science and on the systems and this and that, which is all part of the current training package, it seems to me that it will be really important to train the crew on expeditioning. The crews will have to have, just like you can't convey what it takes to climb Mount Everest, in a classroom, or even with a 2 or 3 day, hike in the Rocky Mountains. Okay, you have to immerse the crew into an expeditioning spirit, mindset, challenge, and decision-making process that's for real, to really enable the crew to have the right reaction, make the right decisions when they need to be made on the moon and Mars. So, in addition to the classical training that I think you would want for all astronauts to have, I would encourage the analogs to be viewed as a place where somehow there's an ongoing program of immersion of the future crew members into just gaining and building up experience with expeditioning. And not just on Devon, of course, Nemo, everywhere.
A question in the back.
Yeah, Marcelo Vázquez again for NSVRI. Just to remind you that we have a long story of use of analog for Apollo program for day training for lunar surfaces operation, and also Skylab. They have a simulated mission before the flight where they tested several elements and mission operation schedule. So it's a whole story actually. We used to have some interesting experience on that. But I want to make a comment also that I completely agree with the panel and when Mike said about how close need to be related to mission operations. But there are also some scientific gaps in our knowledge that need to be addressed that are completely related to the mission operations. I think it's a balance between both that we need to address. But some issues of isolation, psychological stress, that need to be addressed as in relation with the mission operation, but also independent of that, because there is a lot of gaps that we don't know yet that we need to address based on our experience in Antarctica and Nemo. And I think it's the best things to do is to get the best of the best things of each analogs and use the best of that. But one question I have is, okay, if we are lucky and we go back to the moon in 15 years, cross fingers, less, well, to Mars in 20 years, something like that. So why we do this? Why we do this work now? Why do you need to do this work now?
Oh, I think it's huge. It's so important because if we can do realistic analogs with realistic mobility assets and other habitability assets, we can understand now how we want to operate and some of these psychological factors. Big discussion and opinions on the habitable volume that you need, for example. And if you just go to the human factors guys, they're going to say, you need 200 cubic meters for a person, a crew of 4. And maybe they're right, but I think it depends on how it's laid out and privacy and like, for example, in these small rovers that I'm developing, we have a suit port and we can get in the suit and be boots on the surface in 10 minutes. And so that's different. That's different than staying in a can for 300 days. If I can go out in wide open spaces, if the overhead is really that low, and I think we'll get there, on my day off, I might want to go out and take a walk. I think having private sleep stations is important, and we're evaluating all of this. At Pavilion Lake last year, I always tell this story. It was a great science team. I mean, they should all be astronauts. But toward the end of the week, we had accomplished the main objectives, and we were talking about what science to do next. And it got a little bit nippy, as I say. But everyone went back to their own cabins that night. And that really underscored to me the need to have private sleep quarters. And so in the rover, we have these curtains that fold down. You get your own private stateroom. And if you ever reach the point where you're like, okay, I just need some time alone, you can get that. And so I think those things and how it's laid out are important. And I'd rather have that than this huge can that I have to listen to people snoring all the time. So anyhow, and I don't have all the answers, and my opinion is just my opinion, and the purpose of these analogs is to objectively evaluate that, and use the data to make those decisions.
And I wonder, Marcel, if we have enough time. My concern is that we don't have enough time, and we end up training a crew this way, send them to Mars, and then we risk mission failure. So I think I really question if we have enough time, and I thank the heavens that we have all these analogs and that we're doing what we're doing and having meetings like this.
Yeah, we're not early.
Right, I totally concur.
Got a question in the front? A question in the front, and then Lauren, I think you had a question in the back as well. Okay, so if we could get another mic to Lauren.
Tom Lang here from UCSF. I just want to thank the panel for a really fascinating afternoon's discussion. One question I have, and maybe it's more directed to Dr. Otto and the isolation studies that he's been involved with. What has been done to follow the crew during this period in terms of looking at serum markers, like serum inflammatory markers and other increased expressions of cytokines? The reason why I ask is that these factors could impact the kinds of things like the musculoskeletal system and other things that we look at in bed rest analogs. And that leads to the question of, when we look at bed rest studies, to what extent are the kind of isolation factors that you're dealing with incorporated into those studies for kind of a more accurate picture of spaceflight.
Just a couple comments, and actually Dr. Ayton has they have a lot of data on sort of looking at the immune aspects, but one of the interests is stress, and there have been a number of studies in the Antarctic where we've seen elevated cortisol levels, and I think that plays a key role in the chronic stress we see, the biological effects that we see at the cell level, and neurologically, and I think that's having a neurostructural effect on the brain. So I think it's a prime opportunity to get that data in terms of duration, isolation, and confinement on what's happening biologically. And I know, Jeff, you've done a lot of work on the immune system there.
Yeah, but our focus in the research side of things have been on photobiology, and currently we've got a vitamin D randomised controlled trial, and immunology and virology. We've done some work here with Johnson with viral reactivation, and as part of that, some cytokines and serum markers have gone up to NIH, and one of the issues we have is getting that stuff analysed and out in the public arena. In the last 10 years, we've had 15 publications for space analogue work and one MD thesis. I've got another MD thesis being prepared at the moment, and exactly on this work of cytokines and interferons, and that's being worked on in Hobart at the moment, and that work was done in 1986 and 1996 with flow cytometers down in Antarctica, and I know Oliver's doing some this year again, and the key is to get all this stuff out in the peer-reviewed publications, and I don't know what the experience across the panel is of getting that data out and sharing it, and I think it's come up earlier in the morning. It's finishing off the work, getting it out into the public arena and sharing the data. One of the things in Antarctica is that we're bound by the Antarctic Treaty, which means we should share data. Of course, there's a medical confidentiality issue in that, but the whole idea of our SCAR expert group is to get this work out and published and share the data so that we can use it in other extreme environments.
Lauren, did you still have a question in the back? Did you get a mic? Oh, Kaz, did you have a question as well? Why don't we start with Kaz and get the other mic to Lauren?
Comment on the question, Kaz Shimada from JAXA. About the research, as commented by Isar, we did the bisphosphonate research with the bed rest, and now it's flying. Koichi Wakata is the first test subject for that. So if I ask the research for analog for research, definitely yes. And I closely observed the NEMO mission. Also, the Koichi Wakata commanded one of the NEMO mission. He was happy about that. Now he is our first long-duration crew member. And they have to live in the 100% humidity. And I can say that it was a very close to a flight mission. It's an intense mission. So the NEMO as the training or preparation for the mission, if I'm asked, it's a definitely yes. And the social isolation study, unfortunately, it was an observation by JAXA to have the opportunity to watch how the mission fails. One Japanese entrant was exited early in the past IBMP isolation study. So it's not a definitely yes, but I think we had a good lesson. And Chiaki Mukai is trying that JAXA looks more into the analog study. And here's my question: is that so research, training and the preparation, they are positive for analog. And what's their perspective about the outreach and the education? We might have to exclude the Himalayan and Everest from this, but the others, I see some potential. So I'd like to have some comments from the panelists. If how the analog could be applied to education and outreach. And I think some of the projects are working very nicely as an outreach, but there had been no comments from the panelists. I'm curious.
Yeah, Mark, do you want to start with that and then have Christian and then the other panel members?
Sure, and I think that really plays back into the training question. And one of the reasons NEMO's been so successful is because it provides a very mission-like training environment for the astronauts. We have 3 NEMO astronauts on orbit at this moment, and we've used that as a way of training rookie astronauts with a mission experience, and also giving a commander upgrade to people that are going to end up with a command. But we intentionally design not only science, as we've talked about, into these missions, and not only activities that may be related to surface exploration, but also things like educational outreach. And we in fact have quite a few media events and educational outreach events planned in the timelines of every mission. And these are real. Our crew's really connecting with CNN or National Geographic or whatever, and if they say something they wish they hadn't said, it's still going to be out there just like it is during their space flight. So the pressure to perform is real, the visibility is real, and the coolness for a school or a museum or science center connecting up with a crew that's on a real mission is there as well.
Excellent, thanks. Lauren, or sorry,
I was just going to say, Kaz, you really hit a real, something I have a soft spot for, which is doing outreach activities. We did that in Antarctica with Space 2005 Long Beach with a lot of children there. We hooked up with a couple of schools independently on Mount Everest. We actually hooked up with a school here in South Houston, and it's just a magnificent experience. And I think, I would encourage everyone to do that. I'm sure many of you are doing that because you get back way more than what I think the kids receive. But to motivate and inspire ensures a prosperous future for us all and for space flight. And it's incredible what you get back when you do that.
Great, thank you. Excellent discussions about analogs. I'm very interested in analogs, as you heard. I think it's a smart play if you're going to be doing something in spaceflight to really test your measures, your tools, your technologies, your strategies in the analogs and prove them in the analogs so that they do work well in spaceflight. My question is, they are all diverse, and we are learning about the best ways to utilize them so that we can get the most optimal return on them. So my question is, what do we hold constant, and how do we put our requirements into the system so that we can really plan appropriately for using these analogs? For me, for example, duration is very critical. And I've got to have at least a minimum duration so that I can see teams develop and what they call form, norm, storm, and perform. And so you need at least a 21-day duration. And how do I leverage, what do I do to get that constant across the analog so that then we can really look across the other kind of characteristics and make some good sound investments and how to use them?
I can try. The NASA headquarters, in the case of NASA, has actually helped very much with the Directorate Integration Office, the DIO, which is now helping NASA organize, first of all, collect the requests and the needs for analog simulations or tests or field deployments, and then helps essentially create opportunities or assign analog deployments in which these experiments can take place. And even in the Space Mission Directorate, there's also the Moon Mars Analog Missions Activities Program, MAMA program, where scientists can propose to conduct experiments, and where those experiments take place can be either on the existing field campaigns that are being planned by SMD, by ESMD, so for example at Desert Rats or NEMO, or at other sites. So my point is, I think the first step is you define what you need, right? You need a 21-day simulation at least, and the constraints that you are interested in imposing so that your experiment can take place. And then I would say that needs to be conveyed to, at the very least, the DIO at headquarters. But at the same time, talking to those who are around you and who do the analogs, I guess. And in the case of Devon Island, 21 days actually consistent with a summer field campaign. So if that is the duration that's of interest to you, then we can iterate and even create an isolated experiment that will support your needs. If you needed 500 days on Devon Island, it's possible as well, mind you, but it would take more planning. But so I guess my point is the step number one is you define your constraints and requirements, and number two is you find an analog that will support you the best. And you may never find the perfect match as well, so that's possible too.
I'm not sure you can find an analog that will support you the best. And taking off on Mike's comment, you can't have everything all the time. And I think, we're all here because we're talking about collaboration. I think the Russian 500-day study is going to be fascinating from a psychological point of view. I think that's going to tell us a lot, and it's going to tell us that we need to do a lot of work. I think all of these analogs play a role, and maybe we have to use them judiciously, and we can't use them on a continual basis.
I have a question about. I think for the isolation, is very important. It's also very big contribute for the long-term mass exploitation. But in this model, how to think about the lunar gravity effect and mass gravity effect. This is totally different even with microgravity.
Yeah. I think there are people far more qualified than me to respond to that. I think we had some discussion about that today. Dr. Pellis made a very interesting comment about fractional gravity and what we'll gain there and what we'll gain in 5/8 G. Is that transferable or not? I really don't feel qualified to answer that. Maybe is there someone in the audience? That's a very interesting question.
Leroy had a question in the back, and then I think we've got a question over in the corner here.
Good discussion.
Good discussion on analogs. First of all, I want to say I'm a fan of analogs. I like analogs. I was up at Devon Island a couple of years ago with Pascal. No question about their value in testing and research. As far as training goes, though, I think they have their value, but we've got to be careful how we apply it. Now, maybe for a surface stay and so-called what we call generic training, that would be valuable. When you get into flight-specific training, I think I can tell you as a long-duration crew member, the last thing we're looking for is more training. It's packed enough. As far as the space station goes, what we typically or what we used to look at as training for the space station was flying short duration missions aboard the shuttle. And so while I can see the value added in something like NEMO before you go on any space mission, I think you have to weigh the benefit that you're getting, that is, and over the cost and the overhead. That is this a nice to have or is this a requirement? And I can tell you, I would have been pretty upset if someone told me, well, before you go command the International Space Station, even though you've had all this space experience, you have to go through a commander upgrade program and go to NEMO. And I would have seen that as a nice to have as opposed to a requirement. So I think if you have to be careful where you put your requirements in because you might start losing credibility. So you've got to be careful how you use the analogs for training.
Excellent point. Now we have a question in the back, and then we're going to have one final question, and then we'll summarize. Yeah,
I guess mine is a comment coming from the scientist point of view. When we design experiments, you don't change all the variables at once. When you go to make incremental progress on something, you try to change one thing at a time if you can, or if you have to, you change two. So I would follow up on Lauren's question and ask, have you considered, or have you ever done, an assessment of one set of technologies, variables, at each of the different, or at least two of the different analog sites, and then obtain data that tells you the value of doing the experiment, if you will, in place A versus place B versus place C, as opposed to an anecdotal reporting of the value of each place? I don't know whether you've done this.
I can answer that a little bit. With one of my other hats, run the EVA Physiology Systems and Performance Project, and we're very interested in understanding human performance in center of gravity. And we've done tests in NEMO and underwater environment, also in the MBL, and then in the POGO offloading system, and then in the C9 aircraft. And we've looked across the environments to understand what the limitations of them are, and that's been very useful. And there are limitations of each environment, and to quantify that allows you to then optimize the experiments that you do in each of those environments. And so I think, in general, that's a smart way to go about looking at these analogs.
Any other questions? Yeah. Just a microphone just down here. This will be our last question, then we'll just do a summary and we'll wrap it up.
Something simple. I just wondered what you do in training them to avoid boredom and what kind of free time activities that they can plan for when they're on these flights.
Panelists?
That's an issue that we face in the Antarctic, and I think that's a key issue that will be borne out as we get to ultra-long duration missions. And a comment was made earlier about duration and boredom, and going back to Dr. Morikov and the 500-day study and sort of selection, I think that really plays a factor in the type of people you select. You need to select bright, intelligent people, but people who can tolerate boredom. There's a lot of folks who can't tolerate boredom, plus they have to all get along together, and I'm not sure we're placing a premium in the selection for long duration people on emotional intelligence and the ability for people to get along when the chips are down for a really long period of time. And I'd be interested in Jeff's comments, but from looking at our folks in the Antarctic, even the high performers, they will degrade over time. Not as much as the poor performers, but they do degrade, and I would submit that if we subject them to double 2 years or 2.5 years, we're going to see even a greater degradation. So countermeasures, I think, will play a very, very key role. And what about free time activities? What we found in the Antarctic was free time became more and more critical, and I think if you read some of the Russian literature, as cosmonauts have flown longer and longer, and we found the same thing in the Antarctic, people need more free time. They get tired, they get burned out. This is this cognitive deprivation. And what do you do when you're bored? You know, most of the folks in those environments are type A workaholics. You work more. Well, that's actually detrimental. And I think you really need time to de-stress, to get out of the environment. I really think we need to look at virtual reality environments. If we're in an asynchronous environment, receiving video messages from your family, being able to transmit that back to your family, being able to put on a headset, run on the treadmill, and be running on your, the beach in Santa Monica or, out in the Adirondacks on a wooded trail. I think we need to think about those sorts of things. I don't know if Jeff, if you have any comments, or Pascal.
Nothing more to add, really.
Any other comments from the panelists on that final question? Well, thanks very much. Just in closing, I think we can come to consensus that we would all agree analogs are valuable. Do we have consensus on that? We're willing to go there? Okay. So we've concluded that, all right, good. 2 thumbs up. We've concluded that analogs are valuable. So I will finish with 3 closing questions that you can ruminate on for the next half hour or discuss over dinner, whatever you will. The first of these is we've talked about international collaboration. In many of these analogs, we've desired more international collaboration. We've actually tried to go out and get it, but we've had problems getting it. How can we increase the amount of international collaboration we're getting in participating in these analogs? The second is there's this perception that was raised before about some of these analogs as not necessarily having the same credibility as others. Some are referred to as boondoggles and things. How do we go forward and get the appropriate funding that's required to support the isolation studies, the NEMO studies, the Devon Island studies, the Antarctic studies, and the other breadth of analogs that are available? In Canada, we have the Canadian Analog Research Network that is actually very well funded by the CSA, and the CSA puts infrastructure funding into it and also funding for RFPs for experiments to be conducted in the CARN network. Mike has been up to Pavilion Lake, one of the CARN research sites. We'll be going up again this year, and hopefully we'll have 3 astronauts at Pavilion Lake this year. So we need to address 2 issues there, is getting more of the international international participation, getting more of the funding. And my last comment will be, when the ISLSWIG gets together and talks about the international priorities in life sciences research, typically we talk about research in space. Does the ISLSWIG talk about analog environment research? Do we have the same capability of openly discussing the benefits and the disadvantages of the different analogs and creating an opportunity for peer-reviewed science to exist that can then be what I call science of opportunity? So when we throw together a payload for Devon Island this year and we say, wouldn't it be great if we had a circadian physiology experiment in this mission, that we can go to a pre-existing host of previously peer-reviewed science, take that science and implement it into these analog environments? Because I'll tell you, at Pavilion Lake, while we do tremendous astrobiology research and while we're learning a lot about rover operations and things, there's a tremendous amount of behavioral research that could be done and other analog type research that's been done before at Devon and at NEMO. It's just we haven't put together the process to be able to do it. Thanks very, very much, everyone, for staying here till 5:30. Thanks to the excellent, outstanding panelists, and thanks very much.